this video is going to walk you through, okay, the proper way of doing all the problems on your quiz. The first thing I notice, okay, solve by making common bases, is that the common base between both of these needs to be a 2. So I put parentheses around the base, and I'm going to change these bases to something with 2's. A 4 can be written as 2 squared, and an 8 is 2 cubed. A power to a power so powerful we multiply, 2x cubed, and that exponent equals this exponent. How do I solve a cubic? We're going to have to get everything over to one side. I'm going to move stuff to the right. Okay. Minus 3. Oh, I'm sorry, this is an x here, isn't it? And then I have to factor out an x, and that leaves us with x squared minus 3. And so we're getting x plus radical 3 and x minus radical 3. Since this is an exponent problem, we're just going to state the solutions, and we don't have to worry about any extraneous. 3 solutions when you're solving a cubic. Okay, let's take a look at number 2. Okay. I'm going to rearrange this problem. Whenever I have a negative exponent, I'm going to change that to a positive x, and I'm going to flip the base. Okay, so this is going to be a basic decay problem, and then I'll shift it. So for this basic, the points are 0, 1, 1 comma 1/3, and negative 1 gives us 3. Okay, 0, 1, negative 1 gives us 1, 2, 3, positive 1. Okay, so this is decay. I'm going to put a dotted decay right here. Okay, but now I have to do the transformation. I have to shift everything up 3. Okay, so if I take a look at this asymptote, 1, 2, 3, here is the new asymptote, and all of these points, 1, 2, 3, 1, 2, 3, 1, 2, 3, and it's going to be asymptotic right here to the equation y equals 3. Okay, number 3, solve using the log circle. Okay, when you only have one log, we're going to go ahead and circle this up. 4 to the power of negative 2 equals the of. 4 to the negative 2 powers 1 over 4 squared. Okay, and the way that I'm going to solve this is I'm going to add 1 to both sides. So 1 over 16, let's see, how can I write of 1? I'm going to say 16 over 16, and x is equal to 17 over 16. Okay, let's keep going. Number 4, okay, find the domain. When you have a domain problem, okay, you always want to take the log, take the of, and say that it is greater than 0. Subtracting 5 from both sides, the domain is x's have to be greater than negative 5. Number 5, a little more interesting. Okay, I'm going to say that the domain here, this of, has to be greater than 0. Since this is a rational inequality, I'm going to draw a number line. The numbers on the number line are negative 11 and positive 4. Okay, now we're going to test the sections. They're all open bubbles. I'm going to test the number negative 20. Negative 20 makes negative, negative 20 makes negative, so this is positive, and that's exactly what I wanted. In this section right here, I'm going to test 0. The numerator is negative, the denominator is positive. This section is negative and no good. For this last one, I'll test 10. The numerator is positive, the denominator is positive. This is a good section. So the answer is from negative infinity to negative 11, and then 4 to infinity. Number 6, solving a log equation. Okay, I have a log, a number, a log. The approach to this would be to combine two logs. So I am going to move this natural log to the other side, subtract it over, and I'm going to add the 2 to the right. Now I can combine two logs into one log, and I will divide the ofs. Okay. At this point, I am down to one log. I'm going to go ahead and do a log circle. E to the power of 2 equals 4 over x. I'm going to put a 1 and cross multiply. X times e squared equals 4. And I will divide both sides by e squared. We have 4 over e squared. And the last one, holy logs, look at all of them. I can combine 2 logs into 1 log, since the base is 5. And what am I going to do to those ofs? I'm going to multiply them. Over here, I'm just going to write this 1 log. Okay, but I do have a log on the left and a log on the right. That means the ofs are equal. And I end up with a quadratic equation. I solve quadratics by moving everything over to one side and then hope that it factors. This one does factor into 4x minus 1 times x plus 3. So the solutions are 1/4 and -3. But I have to plug them back into the original ofs to make sure they're going to work out okay. This -3 right here, if I put it into that of, that one is not going to work. 1/4 can go on the of. 1/4 there. Can 1/4 go right here? 3 minus 11 times 1/4. That's 3 minus 11 divided by 4. 11 divided by 4 is 2 point something. So that's going to work out. The only solution is 1/4.